Hi class, let's take a look at example 4. Now, this one could be messy. And then here, these type of problems, because you have the e to the x, cosine of x, none of those two are going to differentiate to 0. So you don't have an option of using anything else other than by parts. And it's the same as the previous one. We're going to try one approach. If you see that it doesn't work, we're going to go back and evaluate, well, the u and the dv in a different form. So let me start with let u equal to, and in this case, e to the x is a good option. The dv, you could start with the cosine of x. So cosine of x dx. So that means that the u is equal to technically e to the x dx, and v is equal to a regular, sine of x. So this one's going to be a sine of x. And as we apply the formula, so in this case, let me just say that this is equal to, and let me write it up here. So this is uv minus the integral of v du. So this particular one, it's actually, and let me use a different color because it's going to get messy. So your u and your v, so in this case, it's going to be an e to the x sine of x minus the integral of v du. And your v ended up being the sine of x, and the du, it's your, e to the x dx. Now, it may appear that there was no progress, but something that happens on these problems is that this portion may actually cycle, and then you're able to evaluate or simplify within the equation. So at this point, we're technically not done with the problem. Here, we're going to actually use by parts again. And then careful with the sign, because you technically have a negative on the outside. So by this parts again, I'm going to start again with technically, and I'm going to follow the same procedure. So I'm just going to let u, so let u equal to your e to the x, and then the v is equal to, and let me select the sine of x. So technically the u is equal to e to the x dx. V is equal to a technically negative. So negative cosine of x. Now let me rewrite the entire formula, because this type of integral cycles. I'll explain the cycling in a minute. So we technically still have the integral of e to the x cosine of x dx. This actually came out to be equal to a e to the x sine of x minus, and we still have this portion to deal with. And then inside of this portion, we're still going to use the uv minus the integral of v du. So your u and your v, so you're going to have technically a negative e to the x cosine of x minus the integral of, and this is going to be a v du. So this is going to be a negative cosine of x e to the x dx. And before this gets any messier, let me distribute the actual negative into these two. So let me rewrite the whole line because we need it. So this is still the integral of e to the x cosine of x dx, which is equal to a e to the x sine of x, and technically plus an e to the x cosine of x, and this is going to give us a plus minus the integral of cosine of x e to the x. And let me just stop here for a moment. And two things that happens with integrals involving e's and cosines, or e's and sines, or some other combination of these formulas. Now, this portion that we're getting as the VDU keep showing up over and over, and if you continue to evaluate, it's going to cycle back to what we started with. But on the good news, what you technically have here, and this is not our final answer, I'm just gonna box it in. You technically have an equation. And on the good news, you have an equation with actual like terms. So on the left hand side, which is the integral that you're evaluating, it's an integral of e to the x cosine of x dx. And then as the result of applying a total of 2 evaluation by parts, you end up with, whoops, I forgot the differential. So this should be dx. Did I forget it on the other ones? No, we're good. Hold on, let me fix it. So you can actually treat this as an equation, and what you could do here is the following trick. So you would actually add to both sides the integral of cosine of x e to the x dx, and then plus the integral of cosine of x e to the x dx. Now this makes a bigger mess, but observe what happens as I move to the next page. Since you're adding both integrals, you no longer have a single integral of e to the x cosine x. You now have technically, so I'm just moving to the next page. So you now technically have 2 integral of e to the x cosine of x dx, which is equal to a e to the x sine of x plus an e to the x cosine of x. So e to the x cosine of x, and then at this point you can technically divide by 2 and divide by 2. So we are able to isolate the integral and then rewrite it as e to the x cosine of x dx, which is equal to e to the x sine of x plus e to the x cosine of x over 2 plus the constant of integration. And let me fix my cosine. So this is a cosine of x all over 2 plus the constant. So our final answer ended up being this mess. And as you can see, this one was a little bit into the, we couldn't fit on the first page